Basic pharmacology can be understood under two headings: pharmacokinetics and pharmacodynamics. Pharmacokinetics is what the body does to the drug, and pharmacodynamics is what the drug does to the body. If you have confusion remembering this, remember that pharmacodynamics has a D, so it is the effect of the drug on the body, if it helps. Now, how the body affects the drug, that particular concept can be understood via two concepts. One is Michelis Menten equation and another is Lineweaver Burk curve. Lineweaver Burk curve. Now, if we understand how an enzyme substrate interaction works, we know that there is an enzyme. If we add a substrate, then we get a product. This is the basic framework. If we are plotting this on an XY axis, and on the x-axis we take the substrate concentration and on the y-axis we take the velocity of the equation, then as we increase the substrate concentration, the velocity of the reaction will increase, and as we keep on increasing the substrate concentration, all the substrate binding sites of the enzyme will be saturated and we will achieve the maximum velocity that we can have in that particular equation, in that particular reaction. Once we are able to find Vmax, we can find half Vmax. Now, if we just find out the substrate concentration at which half of the Vmax is achieved, then that point is known as Km. And Km is the Michelis constant. Km is the Michelis constant. Now, just look at this curve. This is the maximum velocity. As we already said that suppose this is the enzyme and we are adding substrate to it. These are the substrate. Suppose and we are getting a Vmax of this. We want to increase the Vmax of this particular reaction to this. Will increasing the substrate increase the Vmax? I hope you understand that increasing the substrate concentration would not increase the Vmax, because already all the substrate binding of sites of the enzyme are occupied. How we can increase the Vmax is if we add enzyme to this particular reaction along with substrate. If we add more enzymes along with substrate, then we can be able to increase the Vmax of this particular reaction. Increasing the substrate would not increase the Vmax. So this is the first principle. Vmax is directly proportional to enzyme concentration. Now let us again bring back the same curve. This is the x-axis, this is the y-axis, and we have a curve like this. Okay, and we said that Km is the substrate concentration at which half of the Vmax is achieved. Now, suppose we have two kinds of substrates, substrate 1 and substrate 2. Imagine that substrate 1 has a lower affinity for the enzyme and substrate 2 has a higher affinity for the enzyme. Now, logically, if we think, if a substrate has low affinity for the enzyme, that means we will need a higher amount of that substrate to attain Vmax. And if the substrate has high affinity, we need less number of substrate to attain Vmax. That means a substrate which has low affinity will have a high Km, and a substrate which has high affinity will have a low Km. So this is the second principle, that Km is inversely proportional to the affinity of the enzyme for its substrate. Inversely proportional to the substrate enzyme affinity. So this is the second principle. Now, it has actually, when we are statistically calculating the Vmax and the Km in the Michelis Menten equation, it is actually difficult to mathematically find out the Vmax and Vmax by 2 in a hyperbolic curve. In a hyperbolic curve, it is difficult to do it, because it has been seen that even if we keep on increasing the substrate concentration, the highest amount of this particular hyperbolic curve never actually reaches Vmax. So if the hyperbolic curve does not reach Vmax, we will not be able to find out the Vmax of a particular reaction, and hence we cannot find the half of Vmax and half of Km. To do away with this problem and to make our mathematical computation more easy, this curve was manipulated in such a way that it could be represented as a straight line. Nothing was changed. Only thing is, the equation has changed in such a way that the hyperbolic curve now changed to a straight line. So that is what led to the finding of the Lineweaver Burk plot. Basically, without going into the mathematics of that, how this thing was achieved is, in the Michelis Menten equation, the velocity of this particular formula has to be remembered. The velocity of the reaction is maximum velocity into substrate concentration by Km plus substrate concentration. This is the equation. Velocity of the reaction, or the rate at which the product is formed, is Vmax into substrate concentration by Km into substrate concentration. We have already dealt with the meaning of Vmax and Km. Now, if we want this hyperbolic curve to become a straight line representation, we can change this equation and make it like this. If we want the hyperbolic curve to become straight line, what we do is we reverse the equation on both sides. Velocity is equal to Vmax into Vmax into substrate concentration by Km plus substrate concentration. So we do reverse the equation. 1 by V is Km plus substrate concentration. We reverse it on the other side also by Vmax into substrate concentration. Now just let us work it out. This is Km by Vmax into substrate concentration plus substrate concentration by Vmax into substrate concentration. If we just write it out, write it out like this, expand the equation like this, so we can see the substrate concentration on both sides on this particular ratio, this A, it cancels out, and we have 1 by V is equal to Km by Vmax into 1 by substrate concentration plus 1 by Vmax. So this is what is plotted on the Lineweaver Burk curve. Let me write it out again. 1 by V is equal to Km by Vmax into 1 by substrate concentration plus 1 by Vmax. So how do we plot it? Let us take y-axis and x-axis. The 1 by substrate, this is plotted in the x-axis, and 1 by V, velocity of the reaction, is plotted in the y-axis, and we get a straight line like this. Now V1 by Vmax, this point is the point at which this particular straight line intercepts the y-axis. Now it is easy to understand. This is velocity and this is velocity. So Vmax will definitely lie on the y-axis. So the point at which this line intercepts the y-axis is 1 by Vmax, and we can find 1 by Km as the point at which this line intercepts the x-axis, because Km is actually substrate concentration. So Km will lie on the x-axis. So this is 1 minus 1 by Km. This is minus 1 by Km. And the slope of this line is what gives us Km by Vmax. So plotting the various parts of the equation, Vmax, Km, substrate concentration, like this is easier, and the computation becomes much more easier to do. So that is why this Lineweaver Burk plot was used. Now this particular plot is very important to understand how reversible inhibitors work. Now, to understand what are reversible inhibitors, we need to understand the type of reversible inhibitions that happen. That we shall be discussing in the next video.